And so this next crew, we've got 3 folks up here, and they're going to be demonstrating 2 different targets. Dylan, Ryan, and DANYAAL.
Thank you. Hi there. I hope everyone's having a good DistrictCon. It's certainly fun. I'm here with my team today. We're all undergraduate students at George Mason. We're representing the Mason Competitive Cyber Club. I'm going to let everyone do their introductions and just get straight into the cool phone stuff. My name's Dylan.
My name is DANYAAL.
My name is Ryan Murphy, hacker handle VWING.
And today we're going to be showcasing a couple of bugs. We actually have 2 slots back to back. So first we're going to be doing our talk titled, or our show off called Wanderlust. It's focusing on the UPNP service of our target. Our target is the Netgear WNR A54T. It went end of life back in 2018. And there's some pretty easy wins, but they're all cool. So I'll let Danny take away the first bug.
Okay. So funny thing first is that this is the same router that my family used. So that's kind of why we chose it. But yeah, straight to the first bug. Should I pull? Yeah. So yeah, right here. So as you can see, this is the vulnerable function in question. When you send a msearch request to the UPnP service running on the router, it's parsed right here, and as you can see, there's a stir copy where the destination is a local stock variable fixed size. So let me go ahead and take a look at our. So as you can see, really basic overflow. We have control of R4 to R8, and as you can see, this is the msearch request that we send, and our payload being the first part, the header actually. So essentially what we do is we have R5 as a pointer to somewhere in the stack where the command will be for the user, and what we're going to do is we're going to return to this address right here in the binary, which moves R5 into RO and then branches the system. So essentially we can call a system with whatever the user dictates. So why don't we go ahead and give this a shot. And we're going to just simply reboot it, and hopefully the demo gods are not against us. I guess the UPnP service is not running.
Virtual machine networking is important to get right when you are interfacing with a router. And I did not do that.
Okay, one more time. Hopefully it works. Let's go ahead and do that. Okay, now I'm connected. All right, there we go. Finally, it's rebooting. So there you go. Our first exploit down.
All right. Textbook stack buffer overflow with stir copy.
Yep, you find them a lot. So much that there's multiple of them in our target. So our second bug is sort of the same. The previous bug targeted the host header of msearch requests. So this one targets a different header, of course. So we see a similar thing going on here. We see a string copy from the ST header directly into a stack-based buffer right here. There are actually 2 paths. The first one copies after UUID if a double colon is not present, and the second one copies everything between UUID and the double colon. So we're just going to go the first path. msearch headers are super easy to send, and also UPnP is on this router, and most, I'd say, on the WAN. That's kind of the whole point of the UPnP service, is to discover stuff. So all these attacks are unauthenticated and can be hit WAN side. Luckily, no one really runs these. I'm just going to also run a reboot command because it's easy to see we have code execution if we just reboot it. And we see it works.
Nice. And a WAN side bug, that's a big deal if you're not used to exploiting routers. Yeah. That's the part that faces the internet.
So I'll be presenting the a bug in SOAP parsing with the UPNP service. This is not the first SOAP bug you've seen here, and I doubt it'll be the last. So for UPNP to map ports to internal IP addresses and similar, you have to provide it a internal IP address, right? So the way that the binary in service is not, excuse me, the way the binary in service parses that internal IP address is not properly sanitized, and so you can simply put malicious data in there. So you see several parameters here. A lot of those are filtered adequately, but the internal IP address is not. So by putting malicious data in that, we can then have that executed in the system call that follows the command string construction that is used in the IP tables. So to demonstrate this, I'm going to run a reboot command again. Try it in true. Okay. And we see it's rebooting.
All right.
So that was it for our first attack surface on this target. UPnP, usually unauthenticated, usually WAN side, hopefully always unauthenticated. Big, simple bugs, not so simple effects on your life, right? You know, hopefully someone doesn't figure out more bugs and just scans the internet looking for these routers. But there tends to be a lot of stuff like that, especially if you're just like searching for deprecated calls. So appreciate it all. We're back. We'll set up for
Very smooth transition between these two. So you
just to come back. So you're saying that one of you, like, this is the router that your parents use or something?
Yeah, for a long time.
Right. Do they still use it?
No.
That's good. All right. Good to know.
not anymore. Sorry?
But I mean, good question though. So like with this, was it you know, they went to Best Buy and bought this back in the day when it was
Honestly, no
current?
idea. This is like when I was a toddler.
Fair enough. That's fair. Cool.
When was the end of life again?
2018-ish, I think.
2018.
Extra good target.
What ID did the command run as? Are you running a group?
Yeah, I think it only, or that's probably not there. Oh. Okay, probably. Yeah,
It looks like
it's running
everything's
as
running
root.
root.
So.
Very typical router moment. Everything runs root.
All right.
Classic pound prompt.
We'll get to our second attack surface. So our second attack surface, it's been a long day, is targeting the HTTPD binary, also a popular target. All our attacks for this one are command injections, and they follow the same pattern. So there are very likely much more of them, just copy and pasted throughout. These ones are all authenticated. These Netgear routers have a default credentials of admin password on configuration on like factory state. And most of these vulnerabilities contact the post CGI endpoint on the web interface. It's funny that this exists because the post CGI endpoint just lets you arbitrarily change NVRAM. So we could just change NVRAM variables through the interface that are used in system commands that are used by the HTTPD binary, and that's mostly what we do, and it's copy and pasted throughout. So yeah, I'll let Daniel take the first and most bullshitty bug out of the way.
So this one is kind of funny. For some reason, Nectar left a web shell interface. Not sure why, but let's go ahead and check it out. It is at the endpoint of command.cgi.
Who would have thought?
So, okay.
Let's complaining because our session timed out, I think. So go ahead and try browsing that again. It wouldn't be a live demo if something didn't go unexpectedly, right?
So you can run commands here. Don't know why they left it here. So
Convenience.
yeah, it's something, right? So what our script does is essentially just visits that endpoint and just runs a command. So
Still counts.
Mind-blowing technology we have here on display.
yeah. So we're gonna go ahead and run that. And this is off base too, so we're gonna have to give its admin password. And then we're just gonna run reboot, and then hopefully. Yep, there it is.
Nice.
To me, the icing on the cake is that the command CGI endpoint is actually so incredibly buggy that half the time it doesn't even return the output of your command to you. And then the only way to solve that is rebooting the router. So it's like, not only does it exist at all, but it's not even very functional. So the next bug I will be demoing is a command injection via PPPoE peer MAC address. So this router saves a lot of its configuration in non-volatile RAM parameters, as a lot of routers do. But what's kind of unique about this one is that this just gets straight up passed to a system call in the sys init binary. Now, the only downside with this bug is that it does require you to have the router configured to use PPPoE as like your ISP authentication and connection method. So, but through the power of like command.cgi, you can just force the router to be in that mode anyways. And so because this gets executed at boot, if I was to put reboot as the parameter to get executed, we would potentially brick the router. I am not going to do that. So I'm going to echo to a file. And because the router just spams ping in the UART terminal, I'm going to add some new lines into this so we can actually see the catted file without waiting 6 minutes for those pings to finish. Okay. And then I'm going to enable force PPoE, the Y parameter in our script. And the script also has the router go ahead and reboot so we can see the command injection execute upon boot. And I think, as Dylan mentioned, you can also change the NVRAM parameters via post.cgi, which is technically what this script uses. Okay, I misspelled pwned, but you know, that's how it goes sometimes.
Yeah, lots of these NVRAM parameters also used in sysinit, so careful not to boot loop yourself for proof of concept if you decide to go after other bugs. This last one is going to be, and I'm going to go through it pretty fast because, again, it's just a copy and paste. And this isn't our last one, second to last one. Where's Binja? Okay. Is another NVRAM parameter, send mail. So the router lets you automatically send emails in the case of certain events triggering. So this is again setting the email address to something bad and then triggering that send mail functionality. We see here another concatenation with a string, send mail, email address. We changed that with post.cgi, concatenated into system. So I'm going to run that. This is not consistent, right? Oh yeah. Reboot.
All right.
All right, and I'll be handling our last command injection via the HTTPD binary. This is in the WAN hostname parameter or NVRAM parameter. So if we go back to the router web admin panel, which hopefully it's up, it might still be rebooting. Okay. So currently it's set to this parameter is set to other because we forced PPOE. And then I go to, I believe it's in basic settings, router status. Somewhere in here, you can find references to the router's model, WNR845T. And this is actually like the WAN hostname NVRAM parameter, which is, again, executed upon the system call in the system init binary. So for yet another command injection, of which this router has many, as you can see, we are going to use WAN hostname exec, provide the router IP address, admin password. It helps if I spell password correctly, pro tip right there. And then we're going to echo another file so we don't brick the router. Okay, let's fire this off. Helps if you actually invoke your script with Python. Okay, you see the router rebooting again to force the execution of this injection upon boot. In fact, in here you can see our previous PPPoE right there is actually echoed out to console. So that file is also going to be created as well, which is why I named this demo or the WAN hostname. Okay, the new lines did not encode correctly, but if I just cat this out a lot, you can see that our write to this file in the temp directory was successful.
Yeah, nice work.
Also recall, these are all committing to NVRAM, so they're persistent, which is pretty funny. Again, it's kind of weird. They just let you change NVRAM from the web interface, but they also have a web shell, so not really. Thank you all for watching our demos.
Yeah, let's hear it for a team of undergrads coming out and presenting in front of a security conference. Awesome. It's really classic bugs and making it rain. Thank you guys. Any reflections from the judges? Comments?
How long did it take you guys to find those bugs? I'm guessing some of them not very long though.
A lot of the web ones an afternoon. And the UPNP ones also quick. I've found two of them the same day I started looking at UPNP. So
That CMD.CGI, did you happen to go looking for that elsewhere?
Like on other families or similar firmware? We haven't. So maybe check out old firmware versions. I believe 1.5.2 North America is the only firmware version for this router. It went end of life. Netgear doesn't want to fix any of the bugs we reported, so.
We'll have to poll the audience to see if anybody else's parents have the newer version. Any other questions from the audience?
I don't know.
It's the
So
same reason they have CMD, not CGI.
this gentleman asked why UPnP is exposed to the WAN. It is. We tested this over the WAN. UPnP is facing the internet, so it's the only service facing the internet. One of our exploit chains we didn't demo here was to just use PnP functionality normally to port forward the web shell. So, any other questions? Okay, thank you.
All right, thank you.